So first we have identified for how many data bits, okay, how many check bits is required. So for example, we have used 4 data bits as an input. We need 3 check bits, okay, using the formula 2 power k minus 1, which is greater than or equal to m plus k, where m is the number of data bits and k is, we are checking it out from 0, 1, 2 and so on, right? That is the number of check bits. Okay, so now we got m plus k, right? So m plus k is 4 plus 3, that is 7, okay? So while we add this function, the Hamming code along with the data bit, now the size of the bit will be 7, that is m plus k, okay? So we are going to arrange, okay? So we have to be very clear with, okay? So there will be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So this is about the m plus k. Okay. So that is, you have check bits and also you have data bits. Okay. So for example, if the input data bit is 1001, okay. So just we have to include here. Okay. The second step is where these check bits we have to insert. That is our important thing. Okay. So we know that is a 7-bit, that is m plus k, but we should know where these check bits, 3 check bits, where we have to include. For that, again, we are going to use another formula, that is 2 power n. Okay. 2 power n to find the position of the check bits C1, C2 and so on. That is, just substitute the value for n is 0, 1, 2. So 2 power 0 is 1, 2 power 1 is 2, and then 2 square is 4 and so on, right? So we need only 3 check bits. Okay. So clearly you can say the check bit is C1, C2 and the 4th bit. Okay. So that's why we are putting it as C4. Okay. So C4. The remaining things and all, it's a data bit. So we need a 4 data bit. So you have to put D3 and then we have to put D5 and then D6 and D7. Okay. So this is how we are going to arrange. Okay. Now you are very clearly that where the check bit is coming. Okay. So this is a C1 and this is a C2. Okay. And then this is C4. The remaining 4 bits we are telling it as a data bit. Okay. So for 4 data bits I need 3 check bits. Okay. So this is how we are going to do the for name. Okay. So now you just make it as 0, 0, 0, 1 and then this is the second bit, so 0, 0, 1, 0, okay, and the next is 0, 0, 1, 1 and the next is 0, 1, 0, 0 and for the 5th bit 0, 1, 0, 1 and for the 6th bit 0, 1, 1, 0 and the 7th bit 0, 1, 1, 1. Okay. So this is how you have 7 bits. Okay, just we are transferring it into the binary value of the bit position. Okay, 7 bit. So the third thing is we have to identify the syndrome word. Okay, we have to find out the syndrome word. Okay, so this is from in the transmitter side. Okay, till now we are not talking about the receiver side. We are talking about only the transmitter side. On the transmitter time, the bit is 1001. That is the correct bit. Okay. So for the correct bit, using this Hamming code, we are going to find the syndrome word. That is the first thing. And the next is at the receiver end, if any small bit it changes, okay, if any one bit it changes, that is the wrong output. So that is the time also we are doing the same procedure and we are going to find the syndrome word. Now we will see how to find the syndrome word. Okay. So what are the check bits we are having? C1, C2 and then C4. Okay. So 3 check bits is required. Okay. So now we are going to find out the syndrome word. Okay. How we are going to find out? For the C1, okay, for the C1, we are going to find out which are all the data bits that is associated with C1. How we can find out which are all the bits which is associated with the C1? Because in C1, the most least bit, okay, the least bit is 1. Okay, so we have to find out which are all the data bits having the most least bit is 1. See, for example, here in D3, it is the most least bit is 1. Okay, and in D5 it is 1, and D7 again it is 1, but in D0 it is 0. Okay, so we should not consider D6, only we are going to consider D3, and the next is D5, and the next is D7. Okay, just we are making an exclusive OR for all these data bits. Okay, so this is how we are going to find the value for C1. Similarly, for C2, how we are going to find out is the second least bit. See, for example, in C2, the second least bit is 1. Okay, so we are going to find out in the data bits which are all the data bits the second least bit is 1. Okay, so when you see in D3 the second least bit is 1, yeah, we have to take it, and D5 it is 0, so we are going to leave it, and D6 you are having the second least bit is 1, and D7 again the second least bit is 1. Okay, so we have to put in the formula D3 plus D6 exclusive or D7. Okay, so this is how we are going to find, okay, for C2. Similarly, for C4, when we see the C4 here, the third, okay, the third least bit is 1. Okay, so we are going to find out in the data bit, okay, which are all the data bit having the third, okay, least bit is 1. So that is D5, D6 and D7. We have to consider D5, D6 and D7. When you consider D3, it is not 1. Okay, so we are leaving D3. So this is how we are going to use the formula. Okay, now we are very clear with how we are going to find the syndrome word when we give an input value for D3, D5, D7 and D3, D6 and D7, D5, D6 and D7. We will get an value, okay, for C1, C2 and C4. Okay, so from C4 to C1, when we arrange the answer, that will give you the syndrome word. Okay, so now we will just substitute the formula here. Okay, so here this is considered D3, D5, D6 and D7. So just substitute the value of D3 here. Okay, you will get 1, and the next is 5 is 0, and the next is D7 is 1. Okay, just find the exclusive OR for it. Okay, how you will find the exclusive OR when you consider here. Okay, so just I will make like a exclusive OR. That is 0 1 means answer is 1, 1 0 means answer is 1, 0 0 means answer is 0, 1 1 means 0. Okay, so this is how you will find the exclusive OR. Just we are going to substitute the value here. Okay, what you will get, 1 plus 1 exclusive OR 0 is 1 exclusive 0 is 1, right? So 1, and the next is 1 exclusive OR is 1 is 0. Okay, so we are getting the result 0. Similarly here D3 plus D6. Okay, D3 exclusive OR D6. So what is the value of D3? 1, exclusive OR D6 is 0, and D7 is 1. So how we are going to find out here? Okay, so 1 exclusive OR 0 is 1, and 1 exclusive OR 1 is, we are getting the result is 0. Okay, so similarly D5, D6 and D7. Okay, D5, D6, D7. So I am substituting directly here. 0 exclusive 0 is 0. Okay, and the next is 0 exclusive 1 is, we are getting value as 1. Okay, so we are getting 1. So D7 is 1. So now the syndrome word for the correct word is from C4, C2, C1 we have to take. So what is the value? 1 0 0. This is the syndrome word. Okay, so this is the syndrome word we are getting. Okay, so just to take it down, that is the syndrome word for this 1001 data bit. Okay, so that is 100. Okay, so this is how we have got the answer. The syndrome word is 100. Now we will go for, if it is and the receiver n, okay, the second bit. See, for example, instead of 0 it becomes 1 1 1 0 1. Okay, just we are going to find, just substitute the same formula here and we are going to find out. Okay, just I will rub the first part of the portion and I will do for the second part, and then we will clearly understand which bit is getting error. which bit is getting error. Okay. So now at the receiver end, okay, so one bit is getting error. So using Hamming code, okay, so only one bit, if it gets changed, then only we can apply this. Okay, we are going to find out the second bit is getting error. Okay, so that is D5 got an error. Okay, so that should be our answer. Okay, so we have to detect which bit is getting error. Okay, so just I am going to substitute the value for C1, C2, C4 for this particular data bit. Okay, so that is in the receiver end. So when you substitute for C1, what will be the value? D3. Now it becomes D3, D5, D6 and D7. Okay, so now just substitute for D3, D5, D7. Okay, so D3, D5 and D7. Okay, so just substitute the value for D3 here, 1 exclusive OR, 1 exclusive OR, D7 is 1. Okay, so what will be the answer? 1 exclusive 1 is 0, right? So 0, 0 exclusive 1 is 1. So we are getting the result as 1, right? So C1 is 1. And now when we go for C2, okay, so D3, D6 and D7. Okay, so that only we have received, right? So just substitute here using at the receiver end. What is the value for D3? 1. D6 is 0. D7 is 1, right? So now when you find out 1 exclusive 0 is 1 and then 1 exclusive 1 is 0. Okay, so we are getting the result 0, right? And again consider for C4. Okay, C4, D5, D6, D7. Okay, so last 3 digit. So 1 exclusive 0 exclusive 1. Okay, so what is the answer you are getting? 1 exclusive 0 is 1 and then 1 exclusive 1 is we are getting 0. Right. So now when you find the syndrome word for the wrong thing, okay, you can clearly say that 0, 0, 1. Okay, this is the syndrome word for the wrong thing. Okay, so initially you got 1, 0, 0. Okay, so just find the exclusive OR of these two syndrome word. Okay, so that is the thing. Now you are very clear with the syndrome word, right? So how you are calculating the syndrome word? We are having 3 check bits, C1, C2 and C4. For that we have identified which are all the data bits which is associated with it, and we have found an exclusive OR for it. Okay, and the next is from the higher bit, that is C4, C2 and C1, we are taking the result, and that is the 3-digit word, that is the syndrome word we have find out for the correct word. Okay, and at the receiver end again we have just applied the formula and we have find out the exclusive OR for which are all the data bits which is associated with C1 for the wrong bit. Okay, and then we got the syndrome word as 001. Okay, so now we are going to find the two. Okay, we have a 2 syndrome words. We are going to make an exclusive OR for it. Okay, so 10 is 1, 00 is 0 and 10 is 1. Okay, so now you can see 101. Okay, 101 means which bit is getting wrong. Okay, so that is the 5. Okay, so that is it is D5. Okay, so the binary value for 5 is 101. Okay, so this is how we can clearly say that the 5th bit, okay, so that is the 5th data bit is D5 is wrong. And the next is we can detect it and finally we can correct that particular word D5 is wrong. This is how we will do data error bit detection and correction if any error occurs. Okay, so I just recollect what are the things we have seen. So what are the steps we are doing for error detection and correction? Initially we are going to know how many check bits is required. Okay, so how many check bits is required? Okay, for that we have used the formula 2 power k minus 1 which is greater than m plus k, and then we have used 2 power n to find out the check bits where we have to fit it. Okay, so that is the second thing. And third thing we have went for finding out the syndrome word. For syndrome word we have did which are all the check bits, which are all the data bits that is associated with the check bits based upon the least value of the bit, whether which is 1. Okay, so we have find out and finding the syndrome words. Okay, so this is for the correct input. Okay, and finally we have to find for the wrong input also another syndrome word, that is at the receiver end. Okay, and find the exclusive OR of these two value, we will find which position is in wrong. All the best.